Hello, everyone. My name is Damir Shamanaev. I'm the author of the Move book and one of the early members of the Sui community. Not Sui, just Move community since 2020. I have been around for a while now, and the topic of my adoration, or like something that I admire in Move, is Move patterns. And today's talk, a hunter's guide to the world of Move patterns. First, a note, all examples in this presentation are written in platform-agnostic Move. So no matter which platform you build for, be it Aptos, Sui, or something else, these examples will work. Some Sui-specific implementations will be covered separately, and there will be QR codes if you want to scan them and if you want to see documentation linked to it. And first, we define the character, the software pattern hunter. It's going to be the world of fantasy and Grimm lords of Move patterns. We're going to hunt 3 of them today, and the first one is omnipotent, the watcher, and the incendiary. But before we start our hunt, we need to define and we need to know what is a pattern. So first of all, a pattern is not a ready-to-go solution for code. It's not like you just copy and paste and there you go, it's a pattern, but it's rather a description or a template for how to solve a problem. And often it's a formalized best practice for solving common problems in application design. And if we were to describe a pattern, we would say that it has a base definition. Normally, it has a source language feature that allows this pattern to exist. And also it has a common application and variations. So the first lord of Move patterns, the capability, looks the biggest, but it's actually one of the simplest ones and one of the most common ones. So if we were to name capability, simply it's an access token. It's something that you store, that you can show and prove that you are eligible, that you can have access to something. It stems from strict types, because in Move, if there is a type, you must pass it to the function if it's in the function signature, otherwise you can't call the function. And also references support. I don't need to give you my metro or subway pass to prove that I own it. I can show it to you without allowing you to modify it. And if we were to represent the capability in as a code, it would look simple. It's just a struct. Typically it has store. In some variations, it also has key. And the use of capability would be to gate some protected function. So if you don't have the capability or a capability, you can't call the protected function in this example. A slightly more complicated example, which also relates to coins, something that we typically encode on chain and we create a Move exists for assets, would be a treasury cap. So in this example, a treasury cap gates the access to the mint function, although the coin created as a result of this mint function can be passed freely. So it's just an example, more practical and more asset related. On Sui, capabilities are typically objects. So you would normally have a key plus an optional store, but often they also have store. And also one slight difference is that in base Move, in the regular Move, capabilities are usually owned by an account, but on Sui, they can be owned by both accounts and objects, and it introduces new patterns such as an object capability pattern. For example, my hero can actually have the key to the gates. So the second lord of patterns is the witness, the most tricky one and the most interesting one, although it may seem complicated at first and it requires knowledge of generics. So it's a static module level authorization, simply described as proof of ownership of type. And it stems from generics and phantom parameters, from the drop ability that I can pass you something that can be discarded, and from the type packing restriction. So you can't pack my type. So if I own the type, I create it and I also can unpack it. Witness is represented, it usually looks like this. So if you see a struct without fields that has drop, normally it's a witness and you can easier navigate through the code. And typically witness exists to initialize some generic type. So here in this example, we have, it's quite complicated one. We have the typed something without the concrete type. With the type parameter W. And when we pass the witness to the new function, we initialize the typed with this type. And it actually allows for abstract class to exist. While we don't have inheritance, and a lot of the patterns that we're used to from the world of object-oriented programming are not available, although witness allows us to have a concrete implementation for a base type. And while we don't, again, have inheritance, we can get something very, very close to it. And so if we were to imagine the coin example implemented with witnesses, we would build it in a way. I mean, this is roughly identical to how we built, similar to how we built it on Sui. So you would have the base coin type of the phantom type parameter t, and the min function would only be available if you can generate a witness. And also the burn function would also be only available if you can generate a witness. So these functions are protected and gated by witnesses. However, the base functions of the coin, such as join and split, can be performed on the coin of any type. So here we have like the whole abstract class concept where we have the base type. It already has some properties, but some specific implementations of it, like more concrete details, how the mint is performed and whether it is allowed, and the same goes for burn, are defined by the implementer, by the module that implements this base type. And here, as you can see, when we call the coin mint in the mint function, we actually pass the initiated, I mean, we pass the struct a packed witness, which is in this example, my coin. So we could have a variation of this pattern. For example, we could add store to it. And so normally, and in the previous example, you see that we initiate witness in the same transaction. So when you call the min function, we actually create the witness, we pack the witness, and then it goes instantly. But we could slightly delay it. For example, if we store the witness somewhere in the storage, and so if you add the store ability, then we could technically store it somewhere and then access it and consume it as a witness later. It acts similar as capability behaves, except that capability is usually used as a reference and witness requires like being passed as a value. So it's more like a one-time capability. Sometimes it is useful when collecting multiple witnesses to perform more complicated way of authorization. Just saying, like, it's not very common to have store and witnesses, but it is possible. And delayed witness would, of course, look like this. Again, just has store and drop, no fields, nothing. We could also have a variation of a witness and add fields to it. So for example, if we were to build an NFT base type that has custom metadata, so we could use this metadata to both authorize the creation of NFT and also perform protected methods or perform some general methods related to this NFT. For example, in this example, the type NFT can be initiated with new and we pass the metadata. So we specify like something like name, age, description, image URL or something, but we could also reuse the same metadata, which is normally stored inside an NFT, as a witness in the function register collection. There is no implementation to simplify things, but imagine that we need to pass a witness there to say that we actually own the T and we can register a new NFT collection in the system. So a more specific implementation for the hunter type, because the topic is the pattern hunter, would be, I would look like this. So in the min function, we actually pass the meaningful name and description for the hunter metadata. But in the register collection, we pass an empty metadata. So technically, it is a metadata normally, but in this case, it acts as a witness to prove that you can pack the metadata, although it's never stored. On Sui, we have a slight variation, and we have, I mean, first of all, we have everything that I've just mentioned, but we also have one more thing that is special to Sui. We have one-time witness. It's a special type of witness that can be initiated only once globally, like all over the network. For example, we want to make sure and we want to guarantee that this coin was created just once, and there is no way to create like a second treasury cap for this coin. It is possible using the one-time witness, and the QR code links to an example of how one-time witness works. So the third lord of move patterns is the hot potato. It's a very simple beast. At the same time, no one knows why it exists, and no one knows if it's scary or if it's useful. It's just there. So hot potato is can be described as a programmable obligation to perform an action by creating an undiscardable struct. Simply put, it's a struct without abilities, so it can be stored, it can be discarded, you can't do anything with it except unpack it. And of course, it comes from ability system and from the type unpacking restrictions. So the only module that defines the hot potato or any struct can pack it and can unpack it. And the simplest version of a hot potato would look like this. So just remove store, remove drop, just leave no abilities, and you get the hot potato. The biggest example that always existed for the hot potato is being able to borrow something within a transaction and then put it back. So flash loans are the biggest, like the more specific example of it. I know that hot potato is used for flash loans, for example, on Aptos. It's a very common scenario, but more general one with borrowing can be implemented this way. So we imagine there is a container type which holds some value of type T. There is a borrow function where we can borrow the value from the container for a while, but it also comes with an application with the hot potato borrow that forces the caller to put back the value into the container to unpack the borrow. So if they don't deal with borrow, the transaction fails. And if there was a test for this function, it would roughly look like this. So if there is a container with some value, like in this case, it's an integer 42, we can borrow the value, we can modify the value, and then we can put it back. So hot potato can also be used not as just an obligation or linking something in the same block and making sure that something is returned if taken. But hot potato also allows linking functions, slightly decreasing the amount of code you write. So for example, if we were to implement a dollar store, if you're not familiar with your United States terms, it's a store where everything costs roughly the same, dollar or less. We could define here multiple ways of buying something. So first we perform the buy function and we pay just coin. And also we can buy with discount, we pay coin and a coupon. So technically the same action, because after that, we want to grab something, for example, a book or a poster. And we could have two functions, both of which take receipt and result in different values. So we have two inputs and two output scenarios. And you could add more scenarios to it without the need to write more functions. It is especially useful when writing upgrade-friendly code. So if you had a function and you add a new strategy, a new potential scenario for your application, you could use the hot potato to link the logic, to add more logic to it, or to link some other logic. And so potatoes on Sui is actually, I was going to add something, but then apparently it turned into a better version of hot potatoes, like a scarier one. And the pattern hunter actually enters the level 2 of the battle with the hot potato, because on Sui, we did not add new features around it, but we have discovered the pattern which became crucial for the recently launched standards and applications on Sui. And the thing that we did with it is we added some information about operation, and then we said that hot potato can go somewhere and it's going to have some rules. And we call this pattern a request and policy. And we discovered that it's one of the best ways to actually encode regulations on chain. So for example, when I go to merchant, I want to buy something and there is an obligation to pay tax. The issue hot potato saying that, hey, this person or someone paid this amount. And with this obligation, I need to go to authority and to approve or perform some actions, for example, a pay tax on this operation or a VAT for this operation to be resolved. The two main components of this pattern is request, something that is issued when the transaction happens, when the first operation happens. And the second part is the policy, which defines what needs to happen in between the purchase and before the resolution for the transaction to succeed. A purchase request for like some merchant could look like this. Maybe we would add price and the seller fields. And the most important part here is storing approvals. And they're stored as type names, thanks to reflection that became possible a couple years ago. And to create a new request, anyone can create a new request. There is no limit to who creates requests and how. So once request is created, it needs to go somewhere. And for that, there needs to be a policy defined. So policy also contains rules, a matching field to the approvals in the request, in the purchase request. And when we try to confirm request, we match what is happening. The number of stamps, the number of approvals collected by the request with the number of approvals, the number of the required approvals in the policy. So what are these approvals and how they look like? Usually we call them rules, and a rule module could look like this. It uses witnesses to stamp something. So I say that hey, for my application, in my policy, whenever you make a purchase, you need to pay a commission or you need to pass a deny list. And then once someone makes a purchase, they need to go to the deny list rule and get a stamp that they're not on the deny list, and then go to the policy to confirm the operation. And the store that would issue the purchase request could roughly look like this. So you get the book and you also get the purchase request, which then you go with to the deny list, and then you confirm it in the matching policy for the book type. Roughly the system, schematically, the system looks like this. Normally we would return the T and the request for T. Sometimes you can just return the request for something if there is no other value. And then we could go, for example, to deny list, to an allow list, or to the limiter. And then we go to the policy, which requires all three rules, and there we confirm the request. If I'm on the deny list, if I'm not allowed to execute this transaction, the deny list will abort, or it will just never give me the stamp. And so the policy then will fail because it is required to pass. We have two standards that utilize this pattern. And the first one is Kiosk, which was created for NFT creators and for commerce as a more general term. On Sui, creators can define their rules in the policy for their assets. So for example, they say, hey, I want everyone to pay royalty, and there are flexible ways of defining a policy. A royalty, there could be a fixed fee, or there could be a percentage-based fee. They could also say that all of the buyers of their NFTs need to pass KYC, and they can change this policy in one moment and effective instantly and globally. And marketplaces can also set their policies, because if there is request for one policy, no one is stopping us from issuing two requests to satisfy multiple policies, and marketplaces effectively do that. So when you purchase something on one of the marketplaces on Sui, you go and satisfy the requirements of the creator of the NFT that you just purchased, but also you satisfy the requirements and the policy that is set by a marketplace. And the rules for both systems or for both parties stay the same. So it's full code reusability, ability to customize and to set any policy rules at any moment without writing any code for it. And same goes for the closed-loop token, the recently launched standard on Sui. We discovered that this whole policy setting actually matches regulations. And for a closed-loop token, a party that wants to create a closed-loop economy, they can set any rules for any actions happening with their token. So it becomes a mix of an abstract class where some methods may not be defined because they're not allowed in the policy, and also the request plus policy pattern, where to perform a certain action, you need to pass certain regulations or certain rules. And the difference between the kiosk transfer policy system and the closed-loop token system is that in the closed-loop token, you also customize per action. So after we handled all the patterns, we returned to the lodge to make some notes about the patterns and like the way we hunt for them. So first of all, if you're looking for patterns, it's great, or just overall want to learn Move deeper and know more about Move, try different application areas. So if you were building only DeFi, or if you were building only NFTs or consumer applications, try building something else that you haven't tried yet. Sometimes it is helpful to, for example, tell yourself, I'm going to build a bank, or I'm going to build a fast pay application, or I'm going to build like an escrow or something. Because you already had expertise in another area, you would see actually some similarities and some tricks that you could also use in this area. And this is a sign of maybe there is a pattern. Also, elegance is the key. Move is the most elegant language I know. And sometimes extremely complex applications can be implemented in just 100 or 200 lines. And it's just going to look great and it's going to feel great because you just discovered a way to solve a lot of problems in a very small amount of code. And also remember that limitations are creativity. Move not having interfaces, or Move not having something else, or Move not having something else is actually a great thing for creativity, because when you still need to do it, you will try to, your brain starts working, you try to bypass this limitation and come up with a new scenario. And this is, again, where you risk of discovering, where there's a risk of discovering something new. And yes, lastly, forget what they taught you in school. Be open-minded when trying new applications. And Move is different. And sometimes you need to like literally forget other programming languages and think in the new paradigm how we could do things in Move. And final notes. So first of all, it's just a beginning. Even though it feels like we have some patterns, there is a lot more to uncover. It took us a year or maybe 2 years to discover the request and policy pattern, which gives a lot of composability and dynamism where we'd never expected it. There's a lot more to discover. So I encourage everyone to just try and not like think that all patterns are defined. Sometimes you can actually discover something more, maybe inspired by another language, maybe inspired by object-oriented programming or something else. It's always nice to look for patterns. And lastly, all the code samples are taken from the second edition of the Move book. Literally all the patterns, all these code samples are there. A lot has changed. The Move book has been outdated for quite some time, but it will be refreshed to match the current background and landscape happening in the Move ecosystem. And lastly, huge thanks to MoveFunds DAO, huge thanks to you for being here. And I'm super happy to actually be able to present on my favorite topics.
Okay, thank you. Thank you, Damir.